All right, so two more quick examples of rational functions that use square root. So we're going to do one with the square root in the top and one with square root in the bottom. Okay, so when the square root is in the top, we know that it can be equal to 0. So I'm going to set that greater than or equal to 0. Okay, the two factors in the denominator, we know that they cannot. That will make it undefined. So x cannot equal -1/2. X cannot equal 1. So these are my three critical points that I'm going to use to make my number line for my sign chart. Okay, so -5 comes from the numerator. That could be equal to, so close circle. The other two from the denominator, they cannot, they get open. All right, now it's not just x equals -5, it's that x has to be greater than or equal to -5. So that means that this interval to the left does not exist, so we're totally going to ignore that. And instead, we're just going to test the other three intervals that I'm left with. So for this first one, I'm going to use, let's say x equals -2. Okay, when I plug that in, I'm going to get a positive on the top and then a negative times a negative on the bottom, which is really a plus. So positive over positive. Let's change my color real quick. Okay, so this interval is a plus. Okay, moving on to this middle one. We could say x equals 0. Okay, so again, plug it into the original. So I'm going to get a positive on the top, square root of 5 is positive, and on the bottom, I'm going to get a positive times a negative. Okay, so this is really plus over a minus. Okay, making that interval negative. So everything coming out of that interval is going to be a negative number. All right, and then last we could use, I don't know, say x equals +2. Okay, so again, we're getting a positive on the top. That's not by coincidence. We set it so that we only got a positive number. Okay, when I plug it in on the bottom, I'm going to get a plus times a plus. Positive over positive. This last interval is plus. Okay, so now we're just going to find our answer. So we want to know, where are we greater than or equal to 0? So greater than or equal to 0 is anywhere that there's a positive or anywhere that there is a 0. Okay, meaning we can include any critical values from the numerator that would make the function equal 0. Okay, so we have two intervals where we are positive. Okay, and that's our final answer for that one. Okay, let's look at our second example. So now we're putting our square root in the denominator. All right, so those two guys on top, x squared equals 0, so we get x equals 0. X minus 4 squared, that just means that there are two sets of those parentheses. They're going to give us an identical value, so I'm only going to do it once. All right, and now the denominator. So the square root still has to be positive, but when it's in the denominator, it is strictly greater than 0. So I have 3 things I need to satisfy on my number line. Okay, I'm gonna start, I'll do some open and close circles. This is open, these two are closed, okay, and greater than -1 tells me that this interval does not exist. Okay, so we can ignore that right off the bat. All right, and let's test some values now. So in between -1 and 0, probably gonna have to use something like -0.5. Okay, when I plug that in, I'm going to get a positive times a positive on the top, and I'm actually going to get a positive on the bottom. Okay, square root of -0.5 plus 1 is positive 0.5. All right, in between 0 and 4, why not just use 1? Okay, so again, positive times a positive in the numerator, and square root of 2 on the bottom, that's going to be a positive number. Okay, and finally, let's use x equals 5. You don't want to go too crazy picking numbers in the interval. Okay, so positive times a positive on top, positive on the bottom. So each one of these intervals is positive, okay? And because we are equal to 0 here, we're really just going to scoot right over the 0 and the 4. We don't have to break to stop for those because we're including positive numbers and we're including 0 values. So from -1 to infinity, we are either a positive or a 0 value. Okay, and that is our final answer. Now, just for the practice, let's think about something. If we wanted strictly greater than 0, okay, our positives and our negatives, our sign chart would stay the same as far as the signs. So each of these intervals would still be a plus, and this one would not even exist. Okay, but now since we're not equal to 0 anymore, we're not using closed circles on the 0 and the 4. So if we strictly wanted to be greater than, we would actually have to break at each of those values. Okay, and we would not include those.